Today we will start with the subject 18FT 305 Basics of Fiber, Yarn and Fabric Manufacturing, and we are at Unit 4 Modern Spinning Systems. Now in the lesson 2 we will talk about different spinning systems, that is rotor spinning, friction spinning, air jet spinning and Bobtex spinning processes. We will see here that how this type of different modern spinning systems it works, and also the principles of operations. Then we will see the spinnability operations and yarn quality of those different kinds of spinning and their applications area and production capability. So these are the areas actually we will cover into these modern spinning systems. Now we will start with rotor spinning. As you can see in the figure, that a schematic view of how the operation takes place. So this involves the separation of fibers by rigorous drafting and then recollection and twisting of fibers in a rotor, as we can see here in the figure. Now what is the principle of rotor spinning? Let us see now. Now this view is a schematic view again of rotor spinning, how this rotor spun yarn is getting produced and what is the principle behind this rotor spinning. Now first principle, if we see the sliver feed, sliver is fed directly. A card or drawframe sliver is fed through a sliver guide, as you can see in the figure, to a feed roller and feed table, and which forwards to a rapidly rotating opening roller, as is seen in the figure. So this is the first principle of rotor spinning. Now let us see in this what is the second principles. So as you are seeing in the image, the operation is sliver opening. In this process, the rotating teeth of the opening roller comb out the individual fibers from the sliver clamped between the feed table and feed roller, and after leaving the rotating opening roller, the fibers are fed to the fiber channel, as is shown in the figure. Now what is the third principles of rotor spinning? Here fiber transport to the rotor, centrifugal forces and vacuum in the rotor housing cause the fibers to disengage at a certain point from the opening roller and to move via the fiber channel to the inside wall of the rotor. So the fiber path is shown in the figure. So this is the third principle of rotor spinning. Now as you can see the photograph of rotor spinning, the fourth principle talks about fiber collection in the rotor groove. The centrifugal forces in the rapidly rotating rotor cause the fibers to move from the conical rotor wall towards the rotor groove and collected there to form a fiber ring. So this is the fourth principle of rotor spinning. Now as is shown in the figure again, the principles, the fifth principle of rotor spinning, that is the yarn formation. Now when a spun yarn end emerges from the draw of nozzle into the rotor groove, it receives twist from the rotation of the rotor outside the nozzle, which then continues in the yarn into the interior of the rotor. So this is clearly seen in the image. So this is the fifth principle of rotor spinning. Now this diagram, as can be seen here, the sixth principle of rotor spinning has been described here, that is the yarn takeoff and winding. What happens here? The yarn formed in the rotor is continuously taken off by the delivery shaft and the pressure roller through the nozzle and the draw off tube and wound onto a cross wound package. So this is the sixth principle of rotor spinning. Now let us see the properties of rotor spun yarn. As can be seen in the photograph, rotor spun yarns are known to be somewhat more extensible, fuller, softer and less hairy. Rotor spun yarn are not as strong as ring spun yarn as we have earlier seen, and the maximum tenacity of the rotor spun yarns is at least 10 to 30%, and in some cases even up to 40% lower than that of the ring spun yarn. So those are the different properties and image of this rotor spun yarn. Now let us see the friction spinning. So what is the principle of friction spinning? As is shown in the diagram, the fibers are delivered onto the drum surface, which transports and stacks the fiber to the fiber bundle, rotating between the two surfaces and moving in opposite directions, as can be shown in the figure of this friction spinning. Now fibers wrapped around the bundle surface. Wrapped fiber bundle, that is called also the yarn tail, is tugged by the yarn delivery roller. Therefore, twist by fiber arrangements are generated. Now, due to separate yarn winding and method of twist insertion, it has the capability to go to high production rate compared to other spinning methods. Now, let us see in the friction spinning the schematic diagram of this, what actually happens. Only the forming yarn rotates at high speed, while the other elements rotate at low speeds. Yarn rotates up to 3 lakh RPM due to very low spinning tension. So you can see this figure, the spinning tension is very low here. Now yarn formation, how the yarn forms in this friction spinning system. So it is shown in one production machine. It consists of 3 distinct operations. Now what are those operations? Number 1 is the feeding of fibers integration, and third one is the twist insertion. So these are the 3 distinct operations in the friction spinning system. Now, as can be seen also in this particular view, the feeding of fibers, how the feeding of fibers takes place. The individual fibers are transported by air currents and deposited in the spinning zone. As also seen in this figure, the direct feed system, the fibers are fed directly onto the rotating fiber mass, that outer part of the yarn tail. So that is shown in this figure, how the direct feed system operates in friction spinning. Now what is indirect feed? Here fibers are first accumulated on the ingoing roller and then transferred to the yarn tail. So this is the indirect feed system in the friction spinning. Now more about the friction spinning, as can be shown in this photograph. The fibers integration. The fibers in this friction drum has 2 possible methods of integration of incoming fibers to the sheath. The fibers assembly completely onto perforated drum before the transfer to the rotating sheath. So this is the way fiber integration takes place, and fibers are laid directly onto the rotating sheath. Let us see the twist insertion, how the twist insertion takes place in friction spinning. As you can see that how the twist insertion, the diagram, how this mass of fibers are operated here. The twist insertion in the open-end friction spinning is shown in this diagram. As can be seen in the friction spinning, twist insertion in core type of friction spinning. So how this core spinning, this takes place in the friction spinning method. Now properties, if you go to the friction spinning, what are the different properties if we want to study, then we can see that different properties are there in this friction spun yarn. Okay, so breaking, elongation of ring, rotor and friction spun yarn is almost equal. Okay, friction spun yarn, this is also drape yarn, have the little bit of bulky appearance. Okay, and bulkier than the ring spun yarn. The twist is not uniform and will differ. So on the yarn surface it will vary. Okay, so it is a little bit of different than the surface structure is different than the ring spun yarn. Now air jet spinning, let us see another method of spinning, how it takes place. The Burrata air spinning system consists of a standard 3/3 high speed roller drafting arrangement as is shown in the figure. Then two compressed air twisting jets are operating here. A pair of take-up rollers and yarn package build unit also is there. The schematic view of air jet spinning can be seen here in this photograph, and resulting yarn consists of a core of parallel fibers and a sheath of wrapped or twisted fibers. So the wrapper fibers are there more in air jet spinning. This is also shown the twisting part. The nozzles of the first jet are said to give a counterclockwise vortex, and this produces a ZS false twist action, and the second jet gives an SZ false twist action. The pressure applied to the jets are such that jet 2 has the higher twisting vortex. So this is the principles of twisting in the air jet spinning. Jet S followed by SZ. So these are the false twist arrangement in air jet spinning. Now as can be seen in this particular diagram, a 3/3 speed roller drafting unit, central cylinder channel, that is the spinning channel, through which the fiber ribbon from the drafting unit passes, and inclined to the channel axis but tangential to its circumference are the four nozzles through which the compressed air is injected into the channel, creating a vortex airflow. So this is the diagram of the air jet spinning, and the quality characterization, if you want to see, less hairiness and clear appearance, high resistance to peeling and abrasion, then high moisture absorption properties are also there in this. Less shrinkage and high wash resistance, and can be spun with various materials such as cotton, synthetic and regenerative fibers and the blended fiber. So these are the different quality of air jet spinning, and structure also is suitable as core yarn. So these are the different properties narrated here. Then finally the twistless spinning, this is the integrated composite spinning. This is also called the Bobtex spinning, and the diagram is before you. A composite yarn, it is formed by melt extruding fibers from a spinneret or by coating filaments with a molten polymer, followed by coating the emerging fibers with short staple fibers, and the resulting matrix is immediately twisted, causing the staple fiber to embed in the extruded fibers before cooling. and the resulting composite yarn is formed at a very high rate spinning, and Bobtex spinning apparatus developed in this process as is shown in the figure. Now this is also called the twistless spinning, and the path of the spinning is shown here. The twistless system, liquid or powder polymer adhesives are applied to the sliver or filament, and the adhesive activated by heating or steam to cause the individual fibers to adhere to one another. In some system, after textile substrate formation from the twistless yarn, the adhesive is removed to improve the aesthetics of the resulting textiles. Adhesives are used including the polyvinyl acetate, polyvinyl alcohol and starch. So these are the twistless spinning different characteristics of twistless spinning, and this is the schematic view. This yarn provided high covering factor as the yarn is flat. The evenness of the yarn is similar to that of the ring spun yarn. Yarn is stiffer with low elongation, and structure of different spun yarns is shown in this figure, and images of spun yarn, then the ring spun, rotor spun, air jet and OE's friction spinning. Now one interesting part is the spinnability, how the spinnability works, quality of being suitable for spinning or the capability of being spun is called the spinnability properties. Now as is shown in this figure, that fiber spinning is a complicated process which is controlled both by the intrinsic parameters of melt such as melt integrity, surface tension, liquid crystallization temperature, etc. So spinnability also talks about the extrinsic properties or properties of fibrillization such as spinning speed, flow rate, external cooling operations, geometry, thermal uniformity, melt die contact or the surface. So let us see the summary of this process, that we have seen the high speed spinning systems, rotor, friction, air jet and also Bobtex spinning, and we have also seen that two different types, that is one is open end spinning system and one is twistless spinning systems. So thank you very much.